Hi, this is Richard Wendell, the founder and CEO of tellic, and today I'm here with my colleague Eric Tanalski, our VP of Data Science and Engineering, to talk with you about biomedical synonym normalization for knowledge graph insight generation. The challenge is that raw biomedical data is 86% unrefined. This challenge occurs at three levels: the entity level, the relationship level, and the graph level. Today we're just going to focus on the challenge at the entity level. The entity level challenge, using disease as an example, you can see three sentences. Firstly, there's a sentence with HBSC disease, and the second two sentences both contain SCD. So the question is, how do we map these to the right disease within our ontology? Well, overall, there are 1.2 million string entities commonly used to refer to different diseases. The fact is, there's really only about 4,500 unique concepts in MESH. This was where the 99.6% unrefined comes from. So with that, I'll hand over to my colleague Eric to talk with you about how we approach solving this problem.
Thank you, Richard. To refine the entities in biomedical data, at the core of our approach is the classification process. When matching a term to an ontology, we compare the NER output with respective ontology terms. Classifier inputs include NER features, ontology concept features, and the character level similarity between the two. Using a classifier instead of pairwise learning to rank allows us to set a minimum threshold for acceptance. If none of the proposed ontology concept matches surpass the threshold, this suggests an NER false positive. We found that this process effectively weeds out NER false positives downstream. Overall, our performance was on par with state-of-the-art solutions. One of the more difficult scenarios to handle are identical acronyms with different definitions. We show that cascading word embeddings at the title, body, and abstract level can have a significant impact on this problem. In this example, our disease NER process detects 3 mentions of PD. Each has a different definition. By comparing the similarity between the embeddings at the title, abstract, and body level with those of the concept, we can accurately resolve the conflict. Note that it was even possible to detect a false positive in the third example. In conclusion, this process increases overall depth of knowledge graph relationships by a factor of 2 to 10x. It is shown to be a powerful way to increase insight generation.